Hey, what's up? Let's try some examples of parallel and perpendicular slopes, parallel and perpendicular lines. Basically, what's going to happen in this lesson, students, is they're going to give you a couple of instructions, a couple of directions, a couple of pieces of information, and you got to make a brand new y equals mx plus b equation. So let's jump right into it. The clues that they're going to give you is that parallel lines have the same slope. All right, so if you want to be parallel with another line, you got to have the same slopes. Like right here, we see we have y equals negative 2x plus 3, and here we have y equals negative 2x minus 1. Same slope. Look at that. They're going to be parallel forever and ever and ever. If you want to be perpendicular, that's what this symbol is. Upside down T means perpendicular. Perpendicular lines, also known as 90 degrees, have opposite reciprocal slopes. Okay, so sometimes I refer to them as the opposite flip. Okay, so opposite means positive or negative, and flip means like literally it's flipped upside down. So if you notice, this third line that goes across here has a y equals 1/2 x plus 3. That's because negative 2, I'll write it over here, negative 2 and positive 1/2 are opposite reciprocals of each other. Okay, the negative 2 is negative, the positive half is positive, and then they're reciprocals as well. 2 and 1/2 are reciprocals. Some other examples of opposite reciprocals would be like 2/3 and then negative 3/2. One's positive, one's negative, and they're flipped. Another example would be like, I don't know, like positive 5 and then negative 1/5. Positive, negative, and then they're flipped. So that's how you make opposite reciprocals. One's got to be positive, one's got to be negative, and then they got to be the flip of one another. That's what reciprocal means. Okay, so basically all they do is they give you clues. So I have a nice little picture to help us here, but here's what we're going to do. We're going to make a new y equals mx plus b equation that hits 4 and negative 1. So this green dot, we got a bullseye this green dot down here. Okay, and we have to be parallel to y equals negative 2x plus 3. So we have to be parallel to this line, okay, and we have to bullseye that 3. So you can physically think about it, it's like you can actually just slide it over, and then you can actually kind of physically see where the y-intercept would be. That's usually the toughest part, is we got to figure out what the new y-intercept is. So if you're parallel, that means you have the same slope. So our slope is going to be the same slope. So we're going to have a slope of negative 2. So I already know my answer is going to be y equals negative 2x, and then I don't know what my new y-intercept is. You could use the slope. I'll show you how to do this physically. You could use the slope and backtrack to find the y-intercept. So a slope of negative 2 means down 2 over 1. So if you reverse that, over 1 up 2, over 1 up 2, over 1 up 2, over 1 up 2, I have a really funny feeling that our y-intercept is going to be 7, but let's save that for later. So you can use a graph to help, but here's how you do it cold and with coordinate points. You got to start off with a blank y equals mx plus b, and then you're going to plug in the x, the y, and the slope. All right, so the y value, that doesn't look like a y, there it is. The y value is negative 1. The slope is negative 2. This is kind of like we did at the introduction if you have a slope and a point. If you have a slope and a point, you plug in those 3 values and you solve for b. And then the x value is 4, all right, plus b. All right, next step, we have to multiply the negative 2 times 4. So we have a negative 1 equals a negative 8 plus b. And then we would add the 8 to both sides to cancel. And then, oh, wow, look at this. b equals 7. Sweet. So I was already given the slope, and I had to calculate the y-intercept as plus 7. Well, I kind of already knew that because I used the slope against this up. I backtracked the slope once, twice, 3, 4 times. Oh, weird. I backtracked the slope, negative 2, 4 times. Backtracked it, took it back, added it. Wow, weird, right? So there's the math. So what I physically did over here, I did mathematically here, and I got back to 7, all right? So y equals negative 2x plus 7 would be, meets the criteria. It's parallel, and it bullseyes the coordinate point 4 and negative 1. So let's see if I can go ahead and drop a line in here really quick. See if I can go ahead and make that line. So it's about up in here, And then it's going to go, that's pretty good. That's not too bad. Let's go ahead and make that bad boy green. And let's give it a little bit of thickness here. There we go. Cool. There you go. I made a new line. It's parallel and it bullseyes the indicated coordinate point. All right. So now we're going to try the second one. So let's go ahead and do the other one. I know this video is kind of long, but you can kind of fast forward and you can skip to the other parts if you want. So let's go red with this one. Okay. Whoops. I didn't mean to do that. There we go. And we're back in frame. Okay. So now again, this one gives you a different set of instructions. Same coordinate point. It's like, oh, we're going to try to hit 4 and -1 again, but this time we want to be perpendicular to -2, to y equals -2x plus 3. Okay, so to be perpendicular, we need the opposite reciprocal slope, which we already know because there's already an example here. So the opposite reciprocal is 1/2. So you got to really pay attention to what type of line they want. If they want parallel lines, use the same slope. If they want perpendicular lines, you have to use the opposite reciprocal. So these questions are really just, what do you do with a slope and a point? What do you do with a slope and a point? It's the same questions we've done before, but they're kind of coded. You kind of have to decode what they want, okay? Translate what they are asking for. Here we go. So I already know my answer is going to be y equals 1/2 x plus b. So I need to figure out what my b value is, all right? So as before, you could, if you want, start at the coordinate point 4, -1. Now we're going to make you red. And then you could use the slope to backtrack to find the y-intercept. Well, a slope of 1/2 is rise over run, would be up 1/2. So you'd be up 1/2. If I reverse that, over 2, down 1, over 2, down 1, over 2, down 1. Ooh, here we go. I have a funny feeling my y-intercept is going to be -3. So that's what I did physically. Let's see if I can do it by hand. All right, here we go. So again, let's start with a blank. Y equals mx plus b. Y value is still -1. My new slope is 1/2. And then my x is still 4 plus b. Okay, here we go. Let's see here. I got to simplify this. -1 is going to equal a 1/2 of 4 is 2 plus b. Final move, -2, -2. b, nice, is going to equal a -3. All right. So let's erase this. My b is -3. So the hardest part of these, especially when you solve them by hand, is finding the new y-intercept. It's pretty easy to figure out what the slope needs to be, but then trying to figure out what the y-intercept needs to be, that can be done either by graph or by hand calculation using your math skills. Remember, if you have the slope and you have an x and a y, you can plug in the slope and the x and the y, and then you can calculate the y-intercept. It's always the toughest part, is finding the missing y-intercept. We need to change this to a different color. Gotcha. All right, cool. All right, so there it is, students. I have made a line parallel to the original equation of -2x plus 3, and it bullseyes this coordinate point. And then I made a perpendicular line, perpendicular to the original line, and bullseyes that coordinate point. So using grid paper, using a graph can help you kind of reconstruct where the slope points to the y-intercept, backtracks to the y-intercept, so to speak. You can also solve by hand. So remember, the same math happens. So in here, physically here, I backtracked the slope 1, 2, 3, 4 times. Oh, look, I applied a half slope 4 times, which is a jump of 2 down 2. Weird, right? Crazy. So anyway, that's about all I got. We will see you in class.